Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Summoning Ritual by Chinstrap. And here are the rules. Fill in the grid with the digits 1 to 9 once each in each row, column, and box. So normal Sudoku rules here. Adjacent digits along a blood-red runes must differ by at least 6. So this is, I forgot what someone nicknamed it as. It's basically German whispers with a difference of 6. So for example, if this were, actually let's use this one. If this were say a 2, this would have to be 8 or 9. Because the only digits that are 6 away from 2 are specifically 8 and 9. And adjacent digits along the red lines, which are the runes, must differ by at least 6. The dotted lines indicates zones of power. Digits may not repeat in a zone, and the value of the zone is a sum of its digits. So it looks like it's typical cage. Yeah, these are typical cages. You cannot have repeats, and the value of the zone is the sum of its digits. Okay. Diagonal arrows indicate ley lines. The value of a ley line is the product of the values of all zones of powers that intersects that ley line. Okay. So ley lines, there's no equivalent really of that. So for example, for instance, the value of the ley line starting with row 1, column 4, so this one, is the product of the two cell zones starting at row 1, column 4. So so it's the product of this value, the product of this value, and the product of this value. Right, the two cell zone starting in row 1, column 4, this two cell zone starting in row 1, column 3, and the 8 cell zones starting in row 4, column 1. So the value of this ley line, which is the arrow, would be the product of the value of this two cell region times the product of this the value of this two cell region times the product of this 8 cell region. And here's the kicker. Every ley line must achieve the same value for successful rituals. So all the ley lines, that the products, they multiply together to form a value, and they all have to be the same for all the ley lines. And after discovering this value, it must be filled in the designated red box at the bottom. So it's implying that's a 3-digit number, which we sort of already sort of figured out, right? Well, maybe I did. Maybe not everybody did. Anyways, so again, the value of the cages are the sum of all the digits in the cage. And there cannot be repeats in the cages. And the value of the ley lines is the product of all the cages that the pointer points through, right? So as I said, for this arrow up here, it sees these 4 cells, which are part of 3 cages. This one, and this one. And so therefore the value of this arrow is the product of those 3 cages. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's just highlight all the different cages. Okay, so... We're going to make this green. There's a 6 cage here. This is a 6 cage or 3 cage. We have a 3 cage here. Another 3 cage here. Gonna make this blue. And this will make, I don't know, green. Make this orange. Okay, so those are all the cages. That's interesting. This has 1, 2, 3 cages multiplied together. This has 3 cages multiplied together. This is 1, 2, 3 also. Oh, that's interesting. That's interesting there. This is only 2? Yes, it's only 2. This is only 2 also, yellow and red. This is 3, which is this green, this blue, and this orange. And those are all the ley lines. Now, the interesting thing about this arrow and this arrow is they share the pink cage in common, and they share the green cage in common. Which means the yellow cage here and this orange cage must add up to the same sum. But, what could it be? So you can have 1, 2, 3, 7, 8, 9 along the ley line. And 3 and 7 can only be at the ends. So this is 1, 2, 3, 7, 8, 9. This is 2, 3, 7, 8. Sorry, not 2, 3. It's 1, 2, 8, 9. This is 1, 2, 8, or 9. This is 1, 2, 8, or 9. And this is 1, 2, 3, 7, 8, and 9. But the thing is, if this is 7, that means these two digits have to add up to 7. But this would also be a high digit, right? Because you'll alternate between 7 can only be next to 1 or 2. Actually, it would only be next to 1, which could only be next to 8 or 9 here. So this can never be 7. This could be 3, but it cannot be 1. It can't be 2 either, right? This is the same as these two digits. So if this is 3, this would have to be 1 or 2, 1 and 2. If this is 8, this would have to be 1 or 2, and this would have to be 9, which doesn't work. So this can't be 8 either. So if this is 3, this could be 1 or 2 with 1 or 2. If this is 9, this would then be 1 or 2, and this would have to be 8, which would force this to be 1. But that doesn't work, though. Right? If this is 9, which forces this to be 1 or 2, that means 8 can only be here, and they would have to be next to 1 or 2 here in both of these cases. But then this would not be 1. So this actually has to be 3. So this is 3, which makes this 1 or 2, and this is 1 or 2. The 3 can only be next to 9 on this line, and the 1 or 2 can only be next to 7 or 8. Okay, so this adds up to 3. This is 3. We don't know what this... So this cage is 36 through 44. This 3-cell cage must be the same as this multiplied by 3. Let's look for the other runes. None of these can be 1, 2, or 3, so this has to be high. These are both high. 7, 8, or 9, 7, 8, or 9. But they're both next to 2 unique digits on this whisper line, or this ley line. So that means they cannot be 7, because 7 can only be next to 1 unique digit, which is 1. So this has to be 8 or 9. This is 8 or 9, which means these have to be both. 8 is next to both of them. So these have to be 1 and 2. 1 and 2 can be next to 7, 8, or 9. And this can't be 1 or 2 because of the 1, 2 pair already in the row. So this can't be 1 or 2. This has to be 3, which forces this to be 9, which makes this 8, which makes this 9. Okay, so this is 37? Is that right? 37? 45 minus 8 is 37. Ooh, that's a prime number. So every other ley line has to have a 37 cage in one of its multipliers. So this is 37. The only ones then are green, blue, and red, which can fill 37. So these have to be 37 also. Since this is 37, this has to be 5 added together. Well, can't be... It's 3 already here, which means it's either 1... It has to be 1, 4 to add up to 8. So this specifically is 1, which makes this 4, which makes that 2. These two digits must add up to 8, so it's either 1, 7, 2, 6, or 3, 5, but 5 and 6 can't be on this whisper line, so this can't be 2 or 3 correspondingly. The rest of these digits are 5 through 9, so this cannot be 5 or 6, this can't be 5 or 6, so therefore these are both high, which makes this a low. So this is 1, 2, and 3 cannot work because it can't be next to 2 unique digits on the whisper line. So this is 1 or 2, which makes this 5 or 6 or 7. If this is 1, this has to be 7, and this is 8, 9. If this is 2, this is 6, and this is 8, 9, right? Because 2 can only be next to 8 and 9 on this whisper line. And if this is 1, this has to be 7, which forces this to be 8, 9. So this is 8, 9 either way. This has to be a low digit next to 8 and 9, so this is 1 or 3. This is a low digit, so this could be 1, 2, or 3 here. And we know that because the blue region has to be 37. Because it's the only region that could fill 37 there. So this is, okay, so this diagonal is yellow times red. So red is 37. So let's make actually all of these digits, these cages that must be the same value, the same. So we're going to make this green and this green. So it has to be the same value here. The yellows must be the same. These must be the same, so we're going to make, I guess, both of those orange. The pink is obviously the same as itself. The yellow is essentially the product of this pink and this orange. Or one of these oranges. This is orange. So this is the orange times the green and the pink. So this does have to be the same as this one. Because this has, the green has to be the same. What do you know about this one, though? This one, we don't know. This yellow has to be the same as this. Because this is just times 2. And it's the 37 cage times the yellow. Same for this diagonal. This diagonal, we don't know. So we're going to make this blue and this red. So the greens are all the same. The pinks are all the same. The oranges are all the same. The yellows are the same. The yellow must add up, or must multiply up to 3 times the pink. What else do we have? Okay. This is next to 3 unique digits on this whisper line, and it cannot be a 9. Therefore, this must be a 1, which must be next to 7, 8, and 9 here. So this is 7, 8, and 9. This must be 7, 8, or 9. We now have a 7, 8, 9 triplet in row 2 and in column 8, which eliminates 7, 8, and 9 from the rest of the row and column respectively. These can't be 1, 2, or 3. These must be 4, 5, and 6 here. This must be 1, 2, 3, 4, 5, or 6. We're not sure. This can't be 1 or 7, 8, and 9. So it's 2, 3, 4, 5, 6 here. The rest of box 3 is 2, 3, 4, 5, 6. But this can't be 3. This can't be 3. This can't be 1 anymore. So this is 2 or 3. This can't be 1 anymore. So this is 2, which makes this a 3. Therefore, this must be 9, which makes this 8. This 2 must be next to a 6 to add up to 8, because this green thing adds up to 37. This can't be 6 anymore here. This could be 1 or 3. That's fine. This can't be 2 or 3. So we have 4, 5, 6 remaining in column 8. This can't be 6, though. This cannot be 8 and 9. What is the high digit amongst these two? It has to be a 7. So this has to be 1 and 7. If this is 7, this would be 1 also. If this is 1, it could be 7 or 8. If this is 7 or 8, this has to be 1 or 2. If this is 1, it could be 7, 8, or 9 here. And if this is 7, 8, or 9, it has to be next to... if it's 7, 8, or 9, it's 1, 2, 3, 7, 8, or 9 here. I'm not sure what that is. Okay. This cannot be 3 and 9. It could be 1, 7, or 2, 8. So we don't know which, though. It has to be 1. It cannot be 2. Because where is the 1 in box 4? Can't be here, can't be here. So it must be one of these. So this is 1 with 7 or 8. Can't be 8, so this has to be specifically 1 and 7 together, because this is 8. Remaining digits in column 3 are 4, 5, and 7, but these can't be 7. Therefore, this must be a 7 here. Sorry, not 4, 5, and 7. 5, 6, and 7. So this is 5 and 6. This is 5 and 6. This becomes 2, 3, 4, 2, 3, 4, 2, 3, 4. No 3 here, though. So this is a 1-7 pair. So if 7 is in either of these, 1 has to be with it. So neither of these can be 7. Therefore, if this is 7, this has to be 1. If this is 1, it has to be 8. Either way, 1 has to be one of these two digits. This is a 2, 3, 4 pair, which eliminates 2, 3, and 4 from the rest of the column, so this can't be 4. This becomes 5, 6, 7, or 8. But 7 can't be either of these. Therefore, we have a 5, 6, 8 triplet, which eliminates 5, 6, and 8 from the rest of the column. So this can't be 5, 6, or 8. So this must be 7. 7 can only be next to 1 on this ley line. So this is a 1, which makes that a 2. This can't be 2 anymore. And this can't be 2. 1 cannot be any of these three. Therefore, 1 has to be one of these. 7 has to be one of these here. 9 has to be one of these. So 1 and 9 are here. The rest of this is 4, 5, 6, and 8. So this has to be 2 with 5 or 6, because 8, and this can't be 2, therefore this must be a 2 here, because of the 5, 6, 8 triplet in the box. Okay, this can't be 2 anymore. Okay. So again, this is 37. One of these is 2, the other one's 3. 9 has to be in one of these. Okay, so if this were 9, even at minimum, that would be 10. And this would have to be 10 times 3, which is 30. And then yellow would have to add up to 30, which is not allowed. So 9 cannot be here. 9 has to be this one. So this is 9. It cannot add up to 12. So this can't be 1 and 3, which would be 4 and times 3. It could have to add up to 15, which could be 1 and 4 here. Or it could add up to 18, which would then be 1 and 8 here. Or 1 and 5 here. So this is 1, 4, or 5. We also know none of these can be 8. This can't be 8. This can't be 8 because this would be too big. This would be 9 times 3, which is 27, and 3 digits cannot add up to 27. So this is 4, 5. This is 3, 4, 5, 6. So 6 has to be one of these cells, and this must be the 8. So this is 8. This cannot be 8. So 7, 8, 8 and 7 are both here. These can't be 9 anymore, which is interesting. And therefore, this can't be 3. 3 can only be next to a 9 on this whisper line, on this ley line. These can't be 6 anymore, therefore this must be 5, and this has to be 8, which makes this a 6. This can't be 6, so this is 5, which means neither of these can be 5. And this can't be 5. Let's see. This adds up to... If this is not 1, this is 7, which forces this to be 1, which makes this 8, and this could be 2 and 8. That's possible. So 1 does not have to be one of these 3 digits. Oh, this pink adds up to the same as this pink, and therefore must be 6. So this has to be 1, 2, and 3. Right? This is 1 or 2. This is 1, 2, or 3. This is 1, 2, or 3. Because that adds up. So this can't be 1 or 2. This can't be 1, which forces this to be 7, which makes this 1, which makes that 8. This is 1 or 2, and this has to be 8 then. This cannot be 7 or 8. This can't be 7. So this is 5 or 6. We have, this has to be 1 and 5 to add up to 6. Because this is the same amount as this. So this is 6, which means this is 18. So it's either 3, 6, or it's 4, 5. So this can never be 2, which means this has to be a 2. There's no other place for it in box 2. This is 3, 6 or 4, 5. So it's either one of these is 3 and one of those is 6. And this is 4 or that's 5. This can't be 5 though, because we already have a 1, 5 pair in the row. So this becomes a 3, 6, 3, 6 pair. So this is 18 adding up to 3 and 6. 2 to add up to 18 has to have 16 here, and therefore it must be 7 and 9. So this is 7, this is 9. This cannot be 7 anymore. So we have a 5, 6, 5, 6 pair in row 7, which eliminates 5 and 6 from the rest of the row. So this must be 7. This can't be 7. This can't be 8 or 8. So this is a 7, 9 pair. And this can't be 9 or 8. This has to be 7. So this is 7, which makes this 9, which makes this 8, which makes that a 7. We also have a 3, 4, 6 triplet in box 3, which eliminates 3, 4, and 6 in the rest of the box. So therefore, this must be 2 and 5 here. This cannot be 2 or 3, therefore it must be a 4 because of the 1, 2, 3 triplet. This can't be 1 because of the 1, 2, 3 triplet, so this must be 7, which makes that a 1. This 4 means this can't be 4, so this is 2. This can't be 2 or 4, so this must be 3. This can't be 2 anymore because of this 2, so where's the 2? It has to be here. So this is a 2. This cannot be 4. This is 5 or 6. This is 5 or 6. We have a 5, 6, 5, 6 pair in row 5, which eliminates 5 and 6 from the rest of the row. So this must be 9, and this must be a 6 to add up with 3 and 9 to add up to 18. Actually, we don't know what that is. Never mind. It's likely... Oh, wait. If this is 3, 6, 9... It has to be a multiple of 18. So this multiplied by the red has to add multiplied to 18. And this is already 12. So you can't have any multiple that's a digit here then except for 1. So this is 1, then this becomes 6. This has to be 3, which means this can't be 3. So this is 6, which makes that a 3. This can no longer be 3. This can't be 6, so this is 4, which makes that a 6. This can't be 4 or 6, so this is 3, which makes that a 1, which makes that 3. This 1 means this can't be 1, so this is 5, which makes that a 1. This 6 means that can't be 6, so this is 5, which makes that a 6. This 6 means that can't be 6, so this is 5, which makes that 6, which makes that 5. This 5 means that has to be a 4. That 4 means this has to be a 6, which makes that a 4. And now we just have to do Sudoku. Remaining digits here are 4 and 8, but this can't be 8, so this is 4, this is 8. Remaining digit here is a 1. Remaining digits here are 3 and 5. This can't be 3, so therefore this must be 5, which makes that a 3. This 5 means this can't be 5, so this is 2, which makes that 5. Remaining digits here are 2 and 4, and this can't be 2, so this is 4, which makes that a 2. Remaining digits here are 6 and 9. This can't be 9, so this is 6, which makes that 9. Remaining digits here are 4 and 5. This can't be 4, so this is 5, which makes that a 4. And the remaining 3 digits here are 4, 7, and 8. So this is 8, this is 7, and that's a 4. Ooh. It didn't solve, so that means we messed up somewhere. Oh, we need to fill this out. That might be what it is. What is it? 37 times 18. Or 3 times 6. 18, 37. 37 times 8. That's 56 in the one spot. 3 times... No, 37 times 8. So 24 in the 10 spot. So 240 plus 56, which is 296, plus 370. So this is 6. 296, so that's 6, 6, 6. It has been done. The Dark One Fistamafel rises. May he forever reign. Spooky. Pretty funny, though, actually. Though we didn't even use the Fistamafel ring, so... But that's still pretty funny. Oh, very cool, actually. Lots of, that's funny. The 666 also was pretty funny. Didn't realize that. Yeah, not too bad. Actually, I would consider it probably easy. It didn't really ever seem challenging, really. I just sort of knew where to go from each spot. I don't know. Maybe for me it's a little easy, but maybe for some people they would find it challenging. Very cool. Very cool ending there with the 666 and the sign of the devil with Fistamafel. which is actually I think is one of the names of this was it Mephistopheles, which is the devil. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.